A NASA telescope is currently hurtling toward Earth out of control. If nothing is done, a collision would soon occur. But NASA is now launching a daring rescue mission that is unprecedented in the history of spaceflight.
Today we're looking at the most exciting space drama of the year and also clarifying how big the potential danger is. And we're getting started right away. Yes, today things get dramatic, folks. Just like in August, by the way, quick announcement, there will be a total solar eclipse over Spain. Let me know in the comments if I should live stream this solar eclipse for you. Just write solar eclipse stream in the comments if you want that. And if there's enough interest, then I'll do that for you in August. And if you don't want to miss it, then subscribe to the channel right now. Then you'll get a notification right in time for the eclipse. And for those who've already subscribed, a thumbs up really helps the video. 5,000 likes should be enough to appease the YouTube algorithm. So now let's dive into the space drama, and it begins in the year 2004.
On November 20th, 2004, a Delta II rocket lifted off from Cape Canaveral and carried a very special passenger into Earth's orbit, the Neil Gehrels Swift Observatory, or SWIFT for short. Incidentally, it is no coincidence that it is named after the bird of the same name, the common swift. That's because SWIFT can align itself with a cosmic event in under 2 minutes, and that's incredibly fast in the world of space telescopes.
But what exactly does SWIFT do exactly? Quite simply, it observes gamma-ray bursts. Gamma-ray bursts are the most violent explosions in the known universe.
When a massive star collapses at the end of its life, or when two neutron stars merge, short but unimaginably intense bursts of radiation are produced. A single gamma-ray burst releases more energy in seconds than our sun does over its entire lifetime of about 10 billion years.
Incredible. Astronomer Neil Gehrels, after whom the telescope was posthumously named or received its name suffix, described its operation like this.
A gamma ray burst goes off, which happens about twice a week. The satellite detects the gamma ray burst and it sends a message down to the ground. And it goes out on a network to our cell phones and we're paged. We look at supernovae, novae, black hole transients, comets, flaring stars, all different kinds of objects.
SWIFT is equipped with 3 instruments for this purpose. A burst alert telescope that continuously scans 1/6 of the entire sky for gamma ray bursts. As soon as it detects one, the telescope automatically swivels toward it, and then the X-ray telescope and the UV telescope spring into action to pinpoint the burst location with millimeter precision and observe its afterglow.
I know, it sounds like science fiction, but it's engineering at its finest. In more than 2 decades, SWIFT has recorded over 1,000 gamma-ray bursts. This has shown us where most of these explosions come from, namely from the death of massive stars in distant galaxies. It helped us detect the brightest gamma-ray burst of all time, which astronomers affectionately call the BOAT. So not GOAT, the greatest of all time, like Lionel Messi or someone, but BOAT, the brightest of all time.
2 years ago, the sun actually got in the way.
You heard right, the sun.
The sun actually goes through an activity cycle about every 11 years.
In 2024, the sun reached its so-called solar maximum. This turned out to be stronger than expected. Among other things, this led to exceptionally strong auroral activity. In some places, the auroras were even visible as far south as southern Europe. Feel free to write to me if any of you saw them back then. I'd be interested to know. The intense solar radiation heated the Earth's outer atmosphere, causing it to expand. And a denser atmosphere means greater drag on satellites in low Earth orbit. SWIFT, which was originally launched at an altitude of 600 kilometers and was supposed to remain active until the early 2030s, suddenly began losing altitude dramatically. By early 2025, its orbit had dropped to around 370 kilometers, and this trend continues to this day. SWIFT is on a collision course with Earth. Without intervention, it would re-enter the atmosphere by the end of this year. But what is NASA doing about it? Brad Sanko, an astrophysicist at NASA's Goddard Space Flight Center and SWIFT's principal investigator, describes the situation as follows. We're working on a timeline here that is simply crazy by spaceflight standards.
Crazy is a good way to put it, because NASA is responding with a measure that is unique in the history of spaceflight so far.
This is just a really different kind of mission. We can't wait long.
Its orbit has been lowering. If we do nothing, SWIFT will re-enter the atmosphere, and so there's nothing to lose.
A private startup was commissioned to build a rescue robot in less than a year for $30 million.
The company is called Katalyst Space Technologies. It's based in Arizona and received the contract in September 2025. 7 months later, its rescue spacecraft was ready, a refrigerator-sized spacecraft weighing about 400 kilograms named Link. Link is equipped with 3 robotic arms and is designed to grasp Swift like a mechanical climber and raise its orbit back to 600 kilometers.
As I'm telling this, I'm realizing it all sounds like something out of a Perry Rhodan novel or something, but it's actually true. Con Healy, CEO of Katalyst Space, says,
"What the team has accomplished in just 8 months is extraordinary. We have designed, built, tested, and integrated a robotic spacecraft intended to carry out one of the most ambitious commercial service missions ever attempted." The crazy thing is that NASA, as a large government agency, isn't normally known for working all that quickly. By comparison, typical NASA missions of this scale often take a decade from concept to launch. Here it took 8 months. Link's launch is scheduled for today, June 27th, not in the traditional way from the ground, but via a Pegasus XL rocket that will be released from a converted Lockheed passenger aircraft called the Stargazer. The launch will take place over the Quadriline Atoll in the South Pacific.
now we're no longer with Perry Rhodan, but rather with James Bond. But even that is all true. And if everything goes according to plan, Link will need 1 to 2 weeks to catch up with Swift. After that, it's going to do something that no commercial spacecraft has ever attempted before.
It will robotically capture an active scientific satellite. No humans, no shuttle, no direct intervention. Everything is autonomous and coordinated from a ground station. Over the course of 6 weeks, Link is expected to gradually use its engines to return Swift to its original altitude. And what is Swift doing in the meantime? Not much. Swift has been completely shut down since February. The mission team has positioned the telescope in a special orientation to minimize drag and ensure that Swift survives long enough for Link to arrive. So scientific operations are on hold. Astronomers in gamma-ray bursts will have to wait. Daniel Purley of Liverpool, John Moores University, a specialist in rapidly changing cosmic events, summed it up: "We already miss Swift a lot. It hurts not to have it available."
And that's not an emotional exaggeration, because Swift is irreplaceable. There is no other telescope that is able to react so flexibly to spontaneous events, changing its course in a matter of seconds and delivering initial data within minutes. During normal operation, 5 to 6 observation requests per day came from research teams worldwide. The late Neil Gehrels, who has unfortunately since passed away, expressed himself in the following beautiful way regarding the telescope.
Life every day for the last 20 years. I love it. It's produced so much great science, and it's been very fulfilling. But every day I think about this delicate instrumentation in the harsh environment orbiting the Earth and how it's able to keep going all of those years. And I very often will just look up at the sky and think about Swift.
If this mission succeeds, it could mark a turning point for the entire space industry. Brad Tenko says it opens many new doors, both scientifically and commercially. One can't help but think of the Hubble telescope, which is also slowly descending and will re-enter the atmosphere in the coming decades. Robotic rescue missions like Link would then be the key, much more cost-effective than a mission with real astronauts, and obviously far less risky for human lives.
Unless someone in mission control trips over a banana peel or something. So the question isn't just, will Swift survive? The question is a new era of robotic satellite technology beginning right here? I find this mission absolutely fascinating.
Not just because of the technology, but because of what it says about us as human beings. When a 22-year-old telescope threatens to fall into Earth's atmosphere, we build a robot in 8 months and send it after it. Because curiosity and science are worth it to us, and because we don't simply abandon the tools we use to understand the universe.
Let anyone try to say something negative about humanity now. Well, okay, I could think of a few negative things, but anyway, I'll keep you updated on all further developments of the NASA rescue mission. So subscribe to the channel now so you don't miss anything, and remember to give a thumbs up so we can hit 5,000 likes. And with that, let's move straight to the next exciting topic.
Because while Swift is fighting for its survival, we now finally know the whole truth about another disaster. Not in space, but in the deep sea. That of the Titan submersible. After a lengthy investigation, we now know how the disaster could have actually happened and what really took place in the final seconds before the implosion. And we're taking a look at the original footage of the Titan's wreckage on the ocean floor. What the investigators have discovered is shocking and raises questions that go far beyond the accident itself. You can watch the video about it in the top right corner. Be sure to check it out, it's very, very fascinating. As always, in the bottom right corner, there's another topic from the worlds of science and space. Otherwise, I'd say see you in the next video. Take care, everyone.